Welcome to the second module of the course, and another step on your way to becoming a data engineer. As engineers, we write programs that do things. And in this module, we're going to write a program that talks to our database, the same database we built in the last module. And when you talk to something new, a person, a machine, a database, you need to know the language it speaks. And that language, my friends, is called SQL. SQL. Weird name, right? But it actually makes a lot of sense. The Q stands for query, meaning you're asking the database something. The S stands for structured, meaning your question has to be written in a very specific way. And the L? Well, that's the language part. So, structured, query, language. And the keyword here is structured. Why structure matters? When you ask a normal person a question, they just get it. Humans can fill in gaps, understand context, and guess what you mean. But the database? No chance. It can't interpret anything. It needs your question structured exactly the way it understands. So, let's take this example. Who our customers are in Knoxville. Now let's figure out how to write that same question in the way the database understands it, using SQL. So the first thing we learned about databases is that they store information in tables. And when we write a SQL query, the very first thing we tell the database is, which table are we looking at? That's what the from clause does. It simply tells the database where the data lives. So we start with from customers because that's the table that has the information we need. Next, we decide what information we want from that table. Remember, your table has multiple columns, and you choose the specific columns you want back. To do that, we use the select clause. So select tells the database what to return. From tells it where the data lives. Now that we're selecting columns from the right table, we may want to organize the results. That's where the order by clause comes in. Order by lets us sort the data, alphabetically, numerically, ascending, descending, however we want. So now our query can get data and organize it. And now comes the most important part of real-world SQL, filtering. This is where the where clause comes in. Where lets us narrow the data down to exactly what we want. In this case, we only want customers who live in Knoxville, so we add a where condition that keeps just those rows. Slide 06 out PNG, and so I used the SQL editor to execute the query, and here are our results. Voila! In the next video, we'll get you set up with your own database so you can run queries yourself. But for now, you can verify the data using the Excel sheets linked in the video description. And so I used the SQL editor to execute the query, and here are our results. Voila! In the next video, we'll get you set up with your own database so you can run queries yourself. But for now, you can verify the data using the Excel sheets linked in the video description. Now we're switching tables, literally. So far, we've been querying customers. But SQL works the same way no matter what table you choose. This time, we're looking at our dog's data. And the question we're trying to answer is super straightforward. Find all Labradors weighing over 50 pounds. So just like before, we'll turn this English question into a structured SQL query, step by step. Step 1 is always the same. Tell the database where the data lives. And because this question is about dogs, we start with the from clause and point it to the dogs table. This is us telling the database, hey, the information we want is stored over here. Next, we choose what information we want back. This question is about the dogs themselves, so we pick the columns that describe them, dog name, breed, and weight. And as we learned earlier, whenever we're choosing columns, we use the select clause. Now it's time to filter the data. The question asks specifically for Labradors, so we add a condition that keeps only rows where the breed is Labrador. This is where the where clause comes into play. It lets us narrow down the table, so we only get the dogs we care about. But we're not done yet. There's one more condition. The question also says the dog must weigh more than 50 pounds. Since we now have two conditions, we need a way to combine them. And that's exactly what the AND operator does. It lets us say, the breed must be Labrador and the weight must be greater than 50. I ran this query in our SQL editor, and here are the matching results. Only the dogs that are Labradors and weigh more than 50 pounds appear in the output. You'll be doing all of this yourself once we get your environment set up. But for now, this is a great example of how SQL lets you turn English questions into precise, structured instructions the database can follow. I ran this query in our SQL editor, and here are the matching results. Only the dogs that are Labradors and weigh more than 50 pounds appear in the output. You'll be doing all of this yourself once we get your environment set up. But for now, this is a great example of how SQL lets you turn English questions into precise, structured instructions the database can follow. All right, time for a quick knowledge check. Your turn to write SQL. Here are 2 beginner-friendly assignments based entirely on what we've learned so far. Assignment 1. Write a query to list all customers who live in Knoxville, sorted alphabetically by last name. Assignment 2. Write a query on the dogs table to find all dogs older than 5, ordered by age from oldest to youngest. Don't overthink it. Just use the same pattern we used in the earlier examples. From, select, where, order by. Pause the video here and give it a shot. Let's look at the solution for assignment 1. To find customers who live in Knoxville, we start by selecting the columns we need. Then we specify the table in the from clause. And finally, we filter the rows by adding a where condition for city equal to Knoxville. That gives us the exact list of customers who match the requirement. And here you can see the query results. These are the customers in our data who live in Knoxville. Now let's look at the solution for assignment 2. We want dogs older than 5 years. So again, we start with a select listing the columns we care about, then the from clause with the dogs table, and then a simple where condition that filters for age greater than 5. This gives us all dogs matching the requirement. And here are the results of that query. These are all dogs in our data that are older than 5 years. Now let's talk about sorting, ordering your results. By default, when you sort in SQL, the order is ascending. That simply means smallest to largest, A to Z. Lowest to highest. So when we apply order by without specifying anything else, that's what the database does automatically. And here you can see the ascending results. The weights go from the smallest number upward. That's the database using the default ASC behavior. And now this is the descending version. DESC flips the order, biggest to smallest, highest to lowest. It's the exact same query, just with the order reversed. Now let's talk about a really common mistake beginners make. Sometimes the way we say things in English sounds like one idea, but in SQL, it actually becomes 2 completely different things. When someone says, find dogs under 20 pounds and also dogs over 60 pounds, it feels like one request in conversation, but it isn't. And depending on what condition you use, you'll either get perfect results or 0 results. This is the classic mistake, using and. And tells the database that both conditions must be true at the same time. But no dog can weigh less than 20 pounds and more than 60 pounds simultaneously. So even though the English sentence felt natural, the SQL version becomes impossible. That's why this approach will always return nothing. And here's the proof, the actual results. 0 rows, because no dog can satisfy both conditions at the same time. This is why understanding how SQL interprets conditions is so important. So what we actually meant in plain English was 2 separate groups of dogs. We want one group, under 20 pounds, and another group, over 60 pounds. To express that correctly in SQL, we use OR, because OR lets either condition be true. This way, the database can return both groups, exactly like we intended. And here's the corrected SQL. Using OR tells the database, if a dog meets either condition, include it in the result. This is one of the most important lessons in SQL. And OR completely change what rows you get back. And now we can see the correct results, all the dogs that match either condition. This matches our real intention much better than the accidental and version we tried earlier. Before we move on, here's a quick summary. Use and when all conditions must be true for the same row. Use OR when you want multiple groups combined into one result. Understanding this difference early makes your SQL far more accurate and saves you from hours of confusion later. Now let's expand a little. SQL gives us a bunch of other comparison operators you'll use all the time. Greater than, less than, not equals, checking for null values, finding text patterns with like, and more. These are the building blocks that make your query smarter and more precise. And that wraps up this module. We've covered how to structure a query, how and OR change your results, and how order by works. In the next module, we'll finally start setting up your own database so you can run all these queries hands-on. You're doing great. Let's keep going.